Good morning, everyone. Myself, Monica Nancy Priya, working as an assistant professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W3017 Embedded C Programming in the Regulation 2021. In today's video, we are going to continue Embedded C Programming in the Unit 3. This session mainly focuses on time delay techniques, input-output programming in 8051 using C, some important logic and data conversion programs which are very important for our future for practicals. Um, then what is the time delay? What is the introduction? What is the time delay? First, in embedded system, we often need to wait for some amount of time before doing the next operation. For example, link LED blinking, motor on and off, sensor stabilization, display refresh, all this need a time delay. If we on the motor, the water is getting filled and we off the motor, it needs a time delay. So in 8051C programming, we can generate delay in two main ways using the 8051 timers and using a simple for loop. What are the methods? These are the methods for the creating a time delay. For loop time delay, this is a for loop. It is very easy to understand. We simply waste CPU time by looping again and again. But the problem is it is not very accurate. The timer based delay uses the internal hardware timer of the 8051. This method is more accurate and reliable, and it is preferred in real time applications too. For example, for the time delay, the assembly instruction, different compilers produce a different code. This is the oscilloscope, and for the time delay function, for the toggle P1 forever with the some delay in between on and off. So we are giving delay time. Then P1 is 0x55. This is the time delay. We are giving a time delay for this is the loop, and for the P1 0x AA, and we are giving the time delay for again this. This is the input output programming in 8051. This is now the delay is not always exact. There are three major factors that affect the accuracy of the delay. First, in the 8051 design itself, so the 8051 execute the instruction in terms of machine cycle. Each machine cycle consists of a fixed number of clock cycles. Then how it means, this is the bit addressable, byte addressable. This is the byte size in the input output. That's a port P0 and P3 are byte accessible. And we use P0, P3 labels are defined in the 8051, the header file. This is the header file, register 51.h, define LED P2. So we have to blink on the LED P2. Here LED is equal to 0. So we have the increment value, the increment P1, that is P2, and the LED blink, that is the P2 value. And the next one is the bit addressable. The bit addressable is nothing but we have the port P0, P3 as the bit addressable, and we use the S bit data type to access the single bit of P0 to P3. So we have the S bit because we have to on the LED of P2. So we are using the S bit. So directly the LED will glow on the P2. It directly access the special function register. So we are using the S bit, and we are going for the logical operations. In the logical operation, in the input output programming also, reading a switch, turning on a LED, controlling a relay. In 8051, we can program all the input output in two ways. That is the bit level input output, that's the byte level input output. We are seeing this, we have seen this, and the bit addressable and byte addressable are also turn on one P1, only P1, and the read only P3. Then it is very useful in switch interfacing, sensor input, interrupt pins, and all. So the next one is the logical operation. This logic operations, are very important in embedded system. They include AND, OR, XOR, NOT, and shift operation. We use these operation to mask bits, test condition, modify one selected bits. So you will frequently use this bit manipulation programs. So the logical operation is very important. And also, we are using this is the logical operation. This P0 and P2 continuously with the 250 milliseconds delay using the inverting and XOR operators. So we are using the MS delay using the logic gates. So this program will delay the 250. MS delay is so 250. So we are using the XOR operators. And the next one is the packed BCD to ACCA. It's a data conversion, which is very important when working with the displays. The BCD means the binary coded decimal. In packed BCD, two decimal digits are stored in 1 byte. But displays like LCD and UART understand only ASCII, ASCII format only. So we need to convert the packed BCD into the ASCII. This type of program is commonly used in digital clocks and meters. We are getting the codes in BCD and we are displaying the code in LCD in ACCIA. Then ACC, ASCII to packed BCD conversion is this is the reverse operation when data comes from the keyboard or serial terminal. It is usually in ASCII format. So, but for the calculation, we need BCD format. So, we have to change it because of this void main. The unsigned character is BCD byte. Unsigned character is W is equal to 4 and Z is equal to 7. So, we are giving the value of W is less than 4. So we are displaying the BCD byte in W bar is it. So the P1, the point port 1, it displays BCD byte. And the checksum byte in ROM. Checksum is used for the error detection. When data is stored in ROM or transmitted, we calculated a checksum value. Later, we recalculate it and compare the answers. If both match, data is correct. If it is not matched, it gives an error. This concept is widely used in embedded system, communication protocols, and firmware validation. Here, unsigned character this is we compare these both the datas and checksum is equal to 0. If it is okay, if it is correct, then it is given a symbol as G, that is good, or else it given a symbol as B, that is bad. So, the conclusion is to summarize this today. What are the slides we have discussed? What are the topic we have discussed? This we learned time delay methods, a factor affecting delays, input output programming, logic operation, data conversion techniques. That is the packaged BCD to ASCII and ASCII to packaged BCD, and the checksum concept. These are the topics we have seen. These are the references of this. Concept. In the next class, we will see more programming examples and applications. Thank you.